Welcome to MathStuber everyone. So today we are going to start with the three-dimensional geometry. That is chapter number 12, 11th, sorry. Three-dimensional geometry. And as we know that um, we have discussed all the things in vector algebra also. What are direction ratios? What are direction cosines? So we are going to start with that only. So if we talk about direction ratios and direction cosines and what is the relation between them. So we know that if we have a vector, suppose there is a vector r vector which is equal to xi cap plus yj cap plus zk cap. Now we can call these x, y, and z as the direction ratios, right? So now what we have is direction cosines are the uh, they actually, if we form a graph here, a three-dimensional graph having x-axis, y-axis, and z-axis mutually perpendicular to each other, and suppose if we have a vector here, let us take this as x comma y comma z. These are the coordinates. This is the point P, and this is a vector r vector, right? That we have taken already, and it is from the origin here. Now the angle uh, from the x-axis is alpha, from y-axis it is beta, and from z-axis it is gamma, right? So these are known as the alpha, beta, and gamma are known as the direction angles. And if we take cos with all these angles, they will be known as direction cosines. So cos alpha, cos beta, and cos gamma. So these are known as direction cosines, right? So these are direction cosines. Now, these cos alpha, cos beta, cos gamma, the direction cosines are denoted by L, M, and N also. So this is L, this is M, and this is N, right? So we can call L, M, N as direction cosines. Now, the direction cosines and the direction ratios are proportional to each other, right? The corresponding direction ratios and direction cosines are proportional. So if the direction ratios and direction cosines are proportional, therefore we can take this as x upon L equal to, and they are equal also. So you can take it as, so we can take this as x upon L is equal to y upon m is equal to z upon n, which is equal to lambda, some constant. So these are proportional to each other, right? Now, if we take the reciprocal of these, if we want to take the values here, and from here we can find the values of x, y, and z also. So it is lambda L, y is lambda m, and z is lambda n, right? So if we take the reciprocal here, let us take L upon X is equal to M upon Y is equal to Z upon, sorry, N upon Z. And let us take it as K. So we are taking it as K. So the value of L will be K into X, M will be K into Y, and N will be K into Z. Right? Now, if we take, as we discussed in the previous chapter also, L square plus M square plus N square is always equal to 1. We know this, right? So if we put all the values here, kx whole square plus ky whole square plus kz whole square is equal to 1. And you can take k square common from these three. So you will get k square into x square plus y square plus z square is equal to 1. K square will be equal to 1 upon x square plus y square plus z square, and k will be equal to plus minus 1 upon under root of x square plus y square plus z square. So this is the value of k. Now if we have the value of k, we can easily find out the values of L, M and N, because they were kx, ky and kz, right? So therefore, the value of L is x upon under root of x square plus y square plus z square, and that will be plus minus. But in the solutions, we usually take plus only. Similarly, this will be plus minus y upon under root x square plus y square plus z square, and n will be equal to plus minus z upon under root of x square plus y square plus z square. So this will be the values of L, M and N. If you are given with the direction ratios, you can easily find out the direction cosines, right? So you just have to find the magnitude of the vector and divide the direction ratios with that magnitude, and you'll get the answer, right? Now, direction cosines, if we want to find out the direction cosines of a line passing through 2 points, and we discussed this also. If suppose direction cosines of a line passing through 2 points. Now, let us say there are 2 points A and B, and one is having x1, y1, and z1, the coordinates, and another is x2, y2, and z2. Right. So the direction ratios of AB will be x2 minus x1, y2 minus y1, z2 minus z1. As I told you that in the last chapter, we did this AB vector is equal to OB vector minus OA vector. So according to this, the direction ratios of the resulting vector AB vector is x2 minus x1, comma, y2 minus y1, and z2 minus z1, right? And if we apply I cap, j cap, k cap along with these, it will form a vector. Now we are talking about direction ratios only. So x2 minus x1, y2 minus y1, and z2 minus z1 are the direction ratios for these points. Now, if we talk about the direction cosines, so we will have to first find out the modulus of AB vector, which is under root of x2 minus x1 whole square plus y2 minus y1 whole square and plus z2 minus z1 whole square, right? And then if we divide this AB vector, magnitude of AB vector with all the direction ratios, you'll get the direction cosines of these. So direction cosines of AB vector will be x2 minus x1 upon magnitude of AB vector. Similarly, y2 minus y1 upon magnitude of AB vector, and z2 minus z1 upon magnitude of AB vector. So these are the direction cosines of the resulting vector, AB vector, right? So that's the easy one. Now, um, if you want to prove that 3 points are collinear, so what we have to do is, so condition for collinearity. So what is the condition for collinearity if suppose there are 3 points A, B, and C, A, B, and C. So what we have to do is, if we want to prove that these points are collinear, then we have to find the direction ratios of AB and the direction ratios of BC vector. And we have to prove that they are proportional to each other. So we can say that A, B, C are collinear if the direction ratios of AB vector and BC vector are proportional, right? So that's the only thing that we have to do. We know how to find out the direction ratios of the vector joining 2 points. We just have to prove that they are proportional to each other. So let's do the questions from exercise 11.1. There are only 5 questions based on these topics. So the first question is, if a line makes angles 90 degree, 135 degree, and 45 degree with the x-axis, y-axis, and z-axis, respectively, find its direction cosines. So that's the easy one because we know the values of alpha, beta, and gamma. So the first question is, alpha is given 90, beta is given 135 degrees, and gamma is given 45 degrees. So we know L is equal to cos alpha, that is cos 90 degree, and cos 90 degree is 0, right? Similarly, M is cos beta, that is cos 135 degree. We have to solve it further. So it is 90 plus 45 degree, and cos A plus B is cos A cos B minus sin A sin B. So sin 90 into sine 45 degree. Now cos 90 is 0 into 1 upon root 2 minus 1 into 1 upon root 2. So it will be minus 1 upon root 2. And similarly, the value of n is cos gamma, and that is cos 45 degrees. And cos 45 degree, we already know it is 1 upon root 2. So these are the values of L, M, and N. So these are the direction cosines, and yeah, that's the thing we wanted to find out. So 0, minus 1 by root 2, and 1 by root 2 are the direction cosines. So you can write at the last, therefore, direction cosines are 0, minus 1 upon root 2, and 1 upon root 2. These are the direction cosines, right? That's the simple one. Now the second question is, find the direction cosines of a line which makes equal angles with the coordinate axis. So alpha, beta, and gamma are equal here. So we have to find the values of the direction cosines. So in the second question, if alpha, beta, and gamma are equal, then cos alpha, cos beta, and cos gamma are also equal, right? Which means L equal to M equal to N. And let us take it as K, right? And we know the property that L square plus M square plus N square equal to 1. So we can take it as 3K square equal to 1. K square will be equal to 1 upon 3, and K will be equal to 1 upon root 3, or plus minus 1 upon root 3. So the values of all these will be Therefore, we can say that the direction cosines are plus minus 1 upon root 3 plus minus 1 upon root 3 plus minus 1 upon root 3. These are the direction cosines, right? Because all of them are equal. Now the third question is we are given with the direction ratios. You just have to find out the direction cosines. So first of all, you have to find the magnitude here and then divide them by direction ratios, and that will be your answer. So in the third question, we just have to find out we have the direction ratios. DRs are given by minus 18, 12, and minus 4. So now if we talk about the um, magnitude first, it is minus 18 square plus 12 square plus minus 4 square. That will be equal to 18 square is 324 plus 144 plus 16. If we add all these, you will get, I think, 4, and this will be 484, and this is the square of, I think, 22, right? So therefore the direction cosines will be given by minus 18 upon 22, 12 upon 22, and minus 4 upon 22. So if we cancel them, these will be minus 9 upon 11, 6 upon 11, and minus 2 upon 11. These are the direction cosines, right? So that's the easy. These are the easy questions. Similarly, in the fourth one, we have to prove that or show that these points are collinear. So as I told you, there is a condition for collinearity that the direction ratios of AB vector and BC vector are proportional. So they should be proportional. If they are proportional, then we can say that the so here the first point is A, B, and C. 2, 3, 4 is the first one, minus 1, 2, minus 1. No, minus 1, minus 2, 1 is the second one. This one, minus 2, 1. And the third point is 5, 8, 7. Now, so we have to first find out the direction ratios of AB vector and BC vector. DRs of AB vector is given by minus 1, minus 2, comma, minus 2, minus 3, comma, minus, sorry, 1, minus 4. So these will be minus 3, minus 5, minus 3. These are the direction ratios of AB vector. Now BC vector. So the direction of BC vector is 5 minus minus 1, 8 minus minus 2, and 7 minus 1. So it will be 5 plus 1, that is 6, 8 plus 2, that is 10, and 7 minus 1 is 6. 6, 8, sorry, 6, 10, 6, and these were minus 5, minus 3, minus 5, minus 3. Now, if we talk about their direction, the proportionality of direction ratios, minus 3 upon 6 is equal to minus 1 by 2. Minus 5 by 10 is also minus 1 by 2, and minus 3 upon 6 is also the same. So all of them are proportional to each other, as we can see, since the direction ratios of AB vector and BC vector are proportional. Therefore, we can say that A, B, and C points are collinear, right? So this is how we have to do the questions. Now, for the fifth question, we have to find out the direction cosines of the sides of the triangle. So you have to first find out AB, the direction ratios for AB, BC, and CA, and then you have to divide them by their magnitudes. So you will get it, right? So you can try this question by yourself. Now let us come to the next topic, which is equation of a line in a space. Equation of a line in a space. There are a few conditions we can find out by which we can find out the equation of a line in a space. So the first condition, space means it's the 3D uh, three-dimensional space. So we have x-axis, y-axis, and z-axis, right? So what will be the equation of line according to the given situation? So the first is if a line passes through a point and parallel to a given vector, right? So we have uh, if a line passes through a point and parallel to a given vector. So let us take this is the three-dimensional space. This is x-axis, y-axis, and z-axis. Let us take there is a line through the three-dimensional space, and it is passing through a point. And the vector joining the origin to this point, let us say it as the a vector. Let us take this point as a, so this will become a vector. This is the origin. And we will take another point which is the variable vector xyz, and let us take this point as p, and the resulting vector is suppose r vector, and also it is given that it is parallel to a given vector. So let us say there is another vector passing from here which is parallel to the vector. Just a second. So let us call this vector as b vector, right? So it is parallel to b vector and it is passing through a vector, a point. So the vector will be a vector, right? So the resulting equation will be r vector equal to a plus lambda b vector. Why is that? Because if they are parallel, if this AP vector is parallel, let us say how this will come. So we know that AP vector is parallel to B vector, right? So the direction cosines of AP vector, no, sorry, the direction ratios of AP vector must be proportional to B vector as they are parallel to each other, right? So we can say that AP vector divided by, or you can say lambda into B vector is equal to R minus A vector, right? Because they are parallel to each other, so it will be equal to lambda B. And now if you take this A vector to the other side, you will get the equation because we want the value for R vector, which is the resulting vector. And this is how we get this equation. So R vector is equal to A vector plus lambda B vector. Lambda is multiplied with B because B is the parallel vector. So the direction ratios will be proportional, right? So you just have to learn this equation only. R vector equal to A plus lambda B vector. A is the A vector is the point from where the line is passing, and B vector is the parallel vector, right? This will be given to you in the question. Now, this is known as a vector equation because we are using vectors here. There is another form of equation also which is known as a Cartesian form according to the given coordinates, right? So we will be talking about both vector equation, vector form, and the Cartesian form. So the vector form we already learned. It is A vector plus lambda B vector. And the Cartesian form, if we talk about, it comes from lambda. If we substitute all the values, let us say if we want to take out the value of lambda from here because it is a constant, so it will be lambda will be equal to r vector minus a vector divided by b vector. So if we talk about all the direction cosines for these, direction ratios for these, so it will be x minus x1 upon a is equal to y minus y1 upon b, and it is equal to z minus z1 upon c. As we know that a vector is equal to x1 I cap plus y1 j cap plus z1 k cap. And the B vector is A I cap plus B j cap plus C k cap, right? So this is how, this is the vector form which can be derived from the vector form. No, this is the Cartesian form which can be derived from the vector form. Vector form you have to learn. Actually, you have to learn both of them, but the Cartesian form can be easily derived from the vector form. So we have to learn the vector form, right? So now, as I told you earlier also in the previous chapter, vector algebra, that the direction cosines can be used in place of direction ratios, but the direction ratios cannot be used in place of direction cosines. So this Cartesian form can also be written as, if we have the direction cosines for the B vector, it can also be written as x1 I cap, y1. So this is x1, x minus x1 upon L, y1, y minus y1 upon M, z minus z1 upon N. Right? So in place of A, B, and C, we can also use L, M, and N if the direction ratios, direction cosines are given. Let us say B vector is given as Li cap plus Mj cap plus Nk cap. In that case, we can use L, M, and N in place of A, B, and C also, right? So both of these equations can be used easily. So let us do the question based on these side by side from exercise 9.11.2, sorry. So the first question, if we talk about, we have to show that the direction cosines are already given to you for three vectors, three lines, and we have to show that they are mutually perpendicular to each other. So uh, we prove that we usually what we do is, if we want to prove that two vectors are perpendicular, we take their direction ratios or direction cosines and multiply them with each other, add them, or you can say that if the dot product of both the vectors is 0, then we can say that both the vectors are perpendicular, right? So that is the thing that we have to do. In the first question, let us take these as L1, M1 and N1. Similarly, L2, M2 and N2. And similarly, L3, M3 and N3 for the first line, second line and third line. So these are given as 12 upon 13 minus 3 upon 13 minus 4 upon 13. Similarly, L2, M2 and N2, 4 upon 13, 12 upon 13, 3 upon 13. And L3, M3 and N3 are given as 3 upon 13 minus 4 upon 13 and 12 upon 13. So these are the direction cosines given to you. Now you have to prove that these are mutually perpendicular to each other. So if we take L1 into L2 plus M1 into M2 plus N1 into N2, put the values 12 by 13 into 4 by 13 plus minus 3 by 13 into 12 by 13 plus minus 4 by 13 into 3 by 13. So 12 fours are 48 upon 169 minus 36 upon 169 minus 12 upon 169. So we can take the LCM here, 169, 48 minus 36 minus 12. And you can see that the answer is 0. So you can say that the first line is perpendicular to the second line, right? So therefore, line 1 is perpendicular to line 2. So this is line 2. Now, again, we will take L2 into L3 plus M2 into M3 plus N2 into N3. And same goes for the line 1 and line 3 also. We will do the same procedure there also. So put the values here. 4 upon 13 into 3 upon 13 plus 12 upon 13 into minus 4 upon 13 and plus 3 upon 13 into 12 upon 13. So if we do the calculations here, you'll get the answer 0 only, right? So you can say that L2 is also perpendicular to L3. Again, we have to do the same thing for L1 L3 plus M1 M3 plus N1 N3, and it will come out to be 0. You can do the calculations, you can put the values and do the calculations. You will see that the answer will be 0. So L1 is also perpendicular to L3, and therefore we can say that all the lines are mutually perpendicular to each other. All the three lines are mutually perpendicular to each other, right? So this is how we have to do the question. That's the easy question. Now the second question, uh, it is saying that show that the line through the points 1 minus 1 2 3 4 minus 2 is perpendicular to the line through the point. Okay. Again, we have to show that they are perpendicular. So we have to find the direction ratios, and then you have to multiply A1 A2 A1 A2 plus B1 B2 plus C1 C2 is also like we were doing here L1 L2 M1 M2 plus N1 N2. So that was because we were given with the direction cosines. If we are given with the direction ratios, we can do this uh, same with direction ratios also. Right. So for the first points, let us take the points as A, 1, -1, 2, and B as 3, 4, -2. So the direction ratios of AB vector will come out to be, let us take them as A1, B1, and C1. So it will be 3 minus 1, that is 2, 4 minus 1, that is 5, and -2 minus 2, that is -4. Similarly, if we take another point here, let us take them as P and Q. Now, another one is let P as -1 minus, sorry, 0, 3, 2, 0, 3, 2, and Q as 3, 5, 6. Right, so these are the 2 points. DRs of PQ vector. It is A1, A2, B2, and C2. And these will be 3 minus 0, which is 3, 5 minus 3, which is 2, and 6 minus 2, which is 4. So if we take now, if we take A1, A2 plus B1, B2 plus C1, C2, and if we put the values here, 2 into 3 plus 5 into 2 and plus minus 4 into 4. You will get 6 plus 10 minus 16, and obviously the answer is 0. Therefore, we can say that both AB vector and therefore AB vector is perpendicular to PQ vector because their coordinates, or you can say the direction ratios, are the multiplication, the sum of the multiplication of or you can say dot product of both of them is 0. So that's why they are perpendicular, right? Similarly, for the third question, we have to prove that they are parallel. And for the condition for parallelism is we have to find out their direction ratios like we have found out here. And we have to show that their direction ratios are proportional to each other. That's it, right? Instead of doing the last step here, this one, A1, A2 plus B1, B2 plus C1, C2, this we will not do. We will take A1 upon A2, B1 upon B2, and C1 upon C2 and make them equal. If they are equal, then the means the lines are parallel. Otherwise, they are not parallel, right? So if we want to show, we have to make them equal. Now the fourth question, which is based on the equations vector and Cartesian form that we have learned so far. Fourth question says that find the equation of the line which passes through the point 1, 2, 3 and parallel to the vector 3 cap plus 2 cap minus 2 cap. So you are given with a vector which is I cap plus 2 cap, the point which is given to you, that forms a vector. And the parallel vector is the b vector, that is given as 3 cap plus 2 cap minus 2 cap. So we know that equation of line is given by r vector equal to a vector plus lambda b vector, and that is I plus 2j plus 3k cap plus lambda into 3I plus 2j minus 2k cap. And if we open all the bracket and solve them, so we have to take I cap, the coefficients of I cap, j cap, and k cap according to that. So it is 1 plus 3 lambda I cap, 2 plus 2 lambda j cap, and plus 3 minus 2 lambda k cap. So this is how we can find out the value of r vector here. So That's it. We wanted to find out the equation of line, and this is the equation of line that we got from the given thing. Now the second thing is uh, means the fifth question here is find the equation of line in vector and in Cartesian form. If it is not given that you have to find it in Cartesian or vector, then you can only do one thing. Means you can find out the vector form. That's it. But if it is given that you have to find vector and Cartesian both, so you have to do it, right? So in the fifth question, we have to find both the forms, right? So, so I'll do since it is the same question, fourth and fifth, so I'll do it for this one only. I will write the Cartesian form also. This was the vector form. This is the vector form. And the same you have to do it in the fifth question also. Now, if we write the Cartesian form here, so it is x minus x1. X1, y1, z1 is 1, 2, 3, which are the coefficients of A vector or direction ratios of A vector. And A, B, C are the direction ratios of B vector, which is the parallel vector. So it is x minus 1 upon 3 is equal to y minus 2 upon 2 is equal to z minus 3 upon minus 2. This is the Cartesian form. And the similar you have to do it in the fifth uh, question, right? So this is how we have to proceed with this. Now, let us do the sixth question. So here also we have to find out the Cartesian equation of the line which passes through the point. So if it is passing through the point, these are given x1 equal to, and we have to find only the Cartesian equation. So we will need only the direction direction ratios. So x1 is minus 2, y1 is also 4, and z1 is minus 5. And also it is given that it is parallel to the given vector, parallel to the given vector, which is given in the Cartesian form, x plus 3 upon 3 is equal to y minus 4 upon 5 is equal to z plus 8 upon 6. Now, it is given in the Cartesian form. There is no direct reference to the uh, parallel vector. So, how can we take the vector which is parallel to the vector which we want to find out? So, obviously, if I give you an example here, let us take three lines like this. Let us take if L1 is parallel to L2 and L2 is parallel to L3, then L1 is also parallel to L3 also, right? So this is the concept we are going to use here. Now we want a vector which should be parallel to the vector which we want to find out, that is R vector. And it is also given that in the question that it is parallel to this vector. Now in the Cartesian form, the coordinates in the denominator or the direction ratios in the denominator shows the parallel vector. So this is the parallel vector to the vector which is given to us. And also we want to find out a vector which should be parallel to this vector. So obviously we are going to use ABC as 3, 5 and 6, right? I hope this is clear to everyone. Um, that we are using this as three line reference. If L1 is parallel to L2, L2 is parallel to L3, then L3 is also parallel to L1. So this in the same way we are using this only. So R vector is parallel to this given vector, and this vector is particularly parallel to 3 I cap, 5 j cap, and 6 k cap. So obviously 3 I cap, 5 j cap, and 6 k cap will also be parallel to the R vector which we want to find out. So therefore, the Cartesian form, because we only want to find out the Cartesian form is given by x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. And also you have to check whether the given vector means the given Cartesian form is in the standard form or not. You have to check the numerators and denominators, everything, right? For plus and minus sign, obviously. So now if we put the values here, this will be x minus minus 2 upon 3, y minus 4 upon 5, and z minus minus 5 upon 6. And if we solve it, you'll get x plus 2 upon 3 is equal to y minus 4 upon 5 is equal to z plus 5 upon 6. And that will be your answer. Right, right. This is the Cartesian form for the equation. Now, in the seventh question, as you can see, we are given with the Cartesian form and we have to write it in the vector form. So that's the easy question. You just have to write because in the Cartesian form, all the three are equal. So we have to just let it as lambda, means we have to take it equal to lambda because it must be equal to some constant. So this is x minus 5 upon 3 is equal to y plus 4 upon 7 is equal to z minus 6 upon 2. So let us take it as lambda and we'll find out the value of x, y and z from here. So it will be x minus 5 upon 3 is equal to lambda, y plus 4 upon 7 is equal to lambda, and z minus 6 upon 2 is equal to lambda. So x minus 5 is equal to 3 lambda, y plus 4 is equal to 7 lambda, and z minus 6 is equal to 2 lambda. X is equal to 3 lambda plus 5, or you can say 5 plus 3 lambda. Y will be equal to 4 minus 4 plus 7 lambda, and z will be equal to 6 plus 2 lambda, right? So therefore you can say that R vector is equal to xi cap plus yj cap plus zk cap. This is the vector form. And if you put all the values here, you will get 5 plus 3 lambda I cap plus minus 4 plus 7 lambda j cap and plus 6 plus 2 lambda k cap. And if you split this whole, you'll get 5 I cap minus 4 j cap plus 6 k cap plus lambda into 3 I cap plus 7 j cap plus 2 k cap. This is how we can write the vector form, right? So this was based on the first thing that we have learned, a vector passing through a point, a line passing through a point, and a parallel vector. So all these questions were based on that. Now let us learn the second thing, the angle between the two lines, right? So if you are given with the two lines, either the direction ratios will be given or direction cosines will be given to you. So we just have to find out the angle between them. Angle between two lines here. So let us take, there are two lines like this. Let us take this as L1 and this as L2, right? and the angle between them, the acute angle between them is theta, let us say. So, and we are given with, at least we are given with something. We must be given with something. So either the equations of L1 and L2 will be given to you in Cartesian form or vector form. Let us take both the examples. So if we are given with R vector equal to A1 vector plus lambda B1 vector and R vector equal to A2 vector plus lambda B2 vector, right? These are the vector forms. If we are given with the vector forms, so how we are going to do it with this is we have to take cos theta equal to because b1 vector and b2 vector are the parallel vectors, so we have to calculate according to them only. So b1 vector dot b2 vector divided by magnitude of b1 vector into magnitude of b2 vector and whole magnitude. So this is the formula if the equations are given in vector forms, right? So you have to just use B1 vector and B2 vector only. There is no use of A1 and A2 vectors here, right? Now, suppose if the equations are given in Cartesian forms, both L1 and L2 are given in Cartesian forms. In that case, L1 and L2. Let us take x minus x1 upon A1, y minus y1 upon b1, and z minus z1 upon c1. Similarly, this is given as x minus x2 upon a2, y minus y2 upon b2, and z minus z2 upon c2. So this a1, b1, c1 are the coordinates for b1 vector, and a2, b2, c2 are the coordinates for the b2 vector, right? In that case, the value of cos theta will be equal to, because it was the dot product of b1 vector and b2 vector, so it will be a1 a2 plus b1 b2 plus c1 c2 divided by magnitude of a1 square plus b1 square plus c1 square into a2 square plus b2 square plus c2 square whole magnitude, right? So this is how uh, we can find out the angle between the two lines if it is given either in vector form or in Cartesian form, right? So from here we can also find out the condition for perpendicularity and for condition of parallelism. So if let us say L1 is parallel to L2. In that case, if L1 is parallel to L2, in that case, A1 upon A2, as I told you earlier also, B1 upon B2 uh, is equal to C1 upon C2. Their um, direction ratios must be proportional to each other. And if L1 is perpendicular to L2, if we want to prove, or if the answer is coming like that, then in that case A1 A2 plus B1 B2 plus C1 C2 must be equal to 0. And the same goes for uh, the direction cosines also, right? If in case direction cosines are given in place of direction ratios, the same thing will follow. So this is how we can find out the angle between the two lines. So let us do or try a question from this. So we will try eighth and ninth question, and one part from each. So eighth question, let us take the first part. So you are given r vector equal to 2i minus 5j plus k plus lambda into 3i plus 2j plus 6k cap, right? And similarly, another R vector 7i minus 6k plus mu. Mu is another constant like lambda I plus 2j plus 2k. So now we have two equations in vector form. So B1 vector here is 3i plus 2j plus 6k cap, and B2 vector here is I plus 2j plus 2k, right? So we know the formula cos theta is equal to B1 dot B2 vectors divided by magnitude of B1, magnitude of B2, and whole magnitude. So if we put all the values here, the dot product of these will be 3 into 1 plus 2 into 2 plus 6 into 2 divided by under root of 3 square plus 2 square plus 6 square into under root of 1 square plus 2 square plus 2 square whole modulus. So cos theta will be equal to 3 plus 4 plus 12 divided by 3 square is 9, 9 plus 4 plus 36 divided by 1 plus 4 plus 9. So 12 plus 4 is 16 plus 3 is 19 divided by under root of 36 plus 4 is okay, this is 49 and this will be 14 under root 14. So 7, this will come out to be 7. So 19 upon 7 root 14. And theta will be equal to cos inverse of this 19 upon 7 under root 14. And this will be the answer, right? So this is how we have to do the questions. Now the next is ninth question. Let us take the first part of this. So in the ninth question, we are given the equations in Cartesian form. First is given as x minus 2 upon 2 is equal to y minus 1 upon 5 is equal to z plus 3 upon minus 3. And the second is, this is L1. The L2 equation is x plus 2 upon minus 1 is equal to y minus 4 upon 8 is equal to z minus 5 upon 4. So as we can see, all of them are in standard form. So we can easily take out A1, B1, C1 and A2, B2, C2. So obviously the denominators are A1, B1, C1, right? So A1 is 2, B1 is 5 and C1 is minus 3. Similarly, A2 is minus 1, B2 is 8 and C2 is 4. So cos theta will be equal to A1 A2 plus B1 B2 plus C1 C2 divided by under root of A1 square plus B1 square plus C1 square under root of A2 square plus B2 square plus C2 square modulus. So just multiply them, minus 2 plus 40 minus 12 divided by under root of 2 square is 4, 5 square is 25 plus 9 under root 1 plus 64 plus 16 modulus, right? So 40 minus 14 is 26. So cos theta will be equal to 26 in the numerator, and here it will be under root of 38, and this will be 81. So 26 upon 9, and root 38 will be written as it is. There are no factors for it. So theta will be equal to cos inverse 26 upon 9 under root 38. And this will be the answer, right? So this is how we can find out the uh, angle between the two lines. Similarly, in the 10th and 11th question, in the 11th question, we have to show that they are perpendicular. And we know that A1, A2 plus B1, B2 plus C1, C2, if it is equal to 0, then we can do it easily, right? So let us try the 10th question. We have to find the value of P if they are perpendicular. And we know the condition for perpendicularity. So here 1 minus x upon 3 is equal to 7y minus 14 upon 2p is equal to z minus 3 upon 2. This is the L1 equation, and the L2 equation is 7 minus 7x upon 3p is equal to y minus 5 upon 1 is equal to 6 minus z upon 5. So these both are at right angle, which means they are perpendicular. It is given to us. Therefore, their A1, A2 plus B1, B2 plus C1, C2 must be equal to 0, right? But first, we have to find out the values of A1, A2, B1, B2, and C1, C2. But before doing that, we have to check whether the lines are, means the Cartesian forms are in standard form or not. So you can see the standard form is x minus x1, but here it is given 1 minus x. So if we take x to the front, you will get x minus 1 upon minus 3. We'll take minus common from the numerator and take it to the denominator. Similarly, the coefficient of y must always be 1. The coefficient of x, y, and z must be 1. So divide all of them by 7. So you'll get y minus 2 upon 2p upon 7, right? And here this is already fine. Similarly, we have to do this for the, so you'll get x minus 1 upon minus 3p upon 7, because we have to take this x to the front, and also we have to remove this 7. So divide all of them by minus 7 now. Now this is fine. Y minus 5 upon 1. Here we have to take minus common. So z minus 6 upon minus 5. Now you have the values for A1, A2, A1, B1, C1, A2, B2, C2. So you apply all the values here. Minus 3, minus 3p upon 7 plus 2p upon 7 into 1 plus 2 into minus 5 is equal to 0. Solve these. 9p upon 7 plus 2p upon 7 is equal to 10. If we take the LCM here, you'll get 11p upon 7 is equal to 10. 11p is equal to 70, and p is equal to 70 upon 11. This is how we will get the value of p, right? So these were the questions based on the two topics that we have learned. So in the next session, we will be talking about the distance between the two lines and other topics that are there. Okay, so Till then, take care, everyone. Bye.